I'm super happy to be here. And in case you don't know me yet, let me introduce myself. Hi, I'm Temporal. Well, Jessica, but you can call me Jess. My pronouns are she and her, and I work as a senior developer advocate at Auth0. If you don't know what Auth0 is, not a problem. We are an identity platform, so we make it as easy as possible for you to implement authentication on your applications so that you can focus on the fun stuff that you want to do for your users, right? We all want to do that. I'm also an instructor at Data Bootcamp and LinkedIn Learning. I'm Brazilian, and I have the first podcast about data science in Brazil called Pizza de Dados. My last project that I just created is called Git Fishes, and is a collection of Git study cards. So if you need help with Git, check it out. Also, you may find me on most social networks under the handle Temporal. So if you are shy and don't want to ask questions right here, you can find me on Twitter later. Cool? But enough about me. And a little disclaimer before we get started. So I come from Brazil, and I know for a fact that most countries that don't speak English as a first language prefer to call JSON Web Tokens JWT. But if you come from an English-speaking country, you might hear the word JWT. So I'm going to be using those two terms along the presentation, so just get used to that. It's a little weird, I might be honest. The first time I ever heard about this, I was like, ooh, interesting, something new. But anyways, you're going to get used to it along this presentation. So it is impossible to start talking about JSON Web Tokens without mentioning the amazing effort that was made to create a collection of standards and specifications that is known as the JWT specification. JWT stands for JSON Object Signing and Encryption, and it brings light to many things that we need to work with JSON Web Tokens and other objects that we might need while working on the web. So part of the JWT specification is the RFC, the Request for Comments 7519, that is commonly known as the JWT or JWT specification. And that's going to be our main focus for today. Let's discuss it. So a JWT, or a JSON Web Token, usually is a standardized string that represents some information. So it conveys some meaning depending on context. But let's take a closer look. So we have three words. JSON, which means how we're going to structure the information that we want to pass from one point A to one point B. Web is the part where everything happens, where we make this information go from one point to another. And the curious thing is, it is a very space-constrained environment. So we need to be mindful of the information we are carrying along these points. And the last part, the token, as a friend of mine likes to say, it usually is a unique identifier that conveys some meaning. So if you've never seen a JSON Web Token before, for those that are new to it, I introduce you to your first JSON Web Token. At a first glance, this gigantic string looks like a random sequence of characters and numbers, but actually, it has a structure. So usually, a JSON Web Token has three parts. The header, that's the beginning of my string. The payload, that is right in the middle, is also known as the body. And the signature is the last part, one of the most coolest ones, if I do say so myself. So the header usually have the information about the token. So what token it is, the token ID, and what type of algorithm was used for signing the token. It is a JSON object, and if you're a Pythonista, you probably know that it looks like a dictionary, right? And this JSON object is then turning into a base64 string so that we can make the first part of our token. Then we have the payload. And the payload carries information about a given resource. In a login scenario, this means resource is my user. So for example, here I have information about me in a scenario that I was like picturing it. So I have the name of the user, I have what it prefers to be called, I have the sub, which is the subject of the token, and in this case, it would be the user ID, and so on. The cool thing about the payload is that it also has the information about when the token expires. So you also have that in there. It's one of the steps that you do for verifying a token. It is also base64 encoded, and you can take that and decode it anywhere. So there is one very important thing about the payload and the header, because they are a little bit different from the signature, is that each key value pair here is what we call claims. And there are actually 3 types of claims. So the first type of claims are the reserved claims. These claims came from the JWT specification. So they are very important because these are the claims like the expiration date, where you can check if a token is expired or not. They have information on who issued that token. And be mindful, this is just an example. And the second type we have are the public claims. They are standardized in a way by IANA, one of the organizations on the internet. And the public claims are made to carry the most common information we usually share when using a token. So for example, if you were to give the information of the first name of the user and the last name, IANA has a standard that says, oh, we're not going to call it first name, we're going to call it given name. And we're not going to call it last name, but we're going to call family name, and so on. There is a long list. The idea is to provide a way for interoperability between systems to happen. So everybody would be speaking, well, the same language. And the last type of claims that we have are the private claims. And they are the coolest, because the private claims are supposed to be anything that you want, anything that your systems need for properly functioning. So as long as you keep a valid JSON object, you can put anything there, anything really. But there is a caveat. First, the more information you put on the JSON Web Token, the bigger the output string you're going to have to pass along in the request that you make. So be mindful of the data you put in there. Keep only the relevant data is a general advice. The second one is, because both of the header and the payload are only base64 encoded, we don't put sensitive data in the token. Well, because anybody that has an internet connection could Google up how to decode a base64 string. It doesn't even have to code, and they could get a hold of that data. So we don't want that to happen. We don't want the data to be publicly available if it is sensitive. Now, you know about the header and the payload. Let's talk about the signature. And the signature is really special, because the signature takes the header and the payload to happen. And depending on the algorithm, a secret or a key. And the interesting thing is, right here, I have a symmetrical algorithm that's HMAC-SHA-256. It only takes a secret, but you may notice that my secret is your 256-bit secret. Not that safe. In real life, you would have something like this. A random string that is generated has a lot of characters to make everybody's lives a little bit safer. So we take the header and the payload together with the secret and a key for signing the token. Now, speaking of algorithms, we have 2 types. This one takes the secret, is the first one, is the symmetrical algorithm. And you can think of a secret. You don't want to share that with everybody, right? So the secret is shared in between the party that signs the token and the party that needs to verify the token. But there is a second type of algorithms. That's the one that I like the most, the asymmetrical ones. Because the asymmetrical algorithms takes a pair of 2 keys, one for signing, the private key, and one for verifying the token, the public key. And you can keep the private key safe and secure and don't have to share it with anyone, and you shouldn't. And you can publish the public key, well, so that anybody could verify the token that you signed to make sure that it was really you. If you were implementing a web application, for example, and if you were using Auth0, for example, Auth0 would create the tokens for you, and you could get the public key from a well-known endpoint so that you could validate that the token came from Auth0. You could also validate whether or not this token was tampered with, because the signature allows us to do that. Because the only person that should be able to sign that token is the person that is holding the secret or the private key. keeping your data a little bit more safer. Now, speaking of keys, there is a format for you to share your keys along. And if you're following OpenID Connect, you're going to have an endpoint that has a format like other JSON Web Token. And this is defined by another RFC, that is the 7517, and it looks like this. So it has a bunch of information there. Because key pairs are bound by mathematical properties that you don't need to know if you don't want to, or if you're not interested in cryptography, so, well, it is up to you. And most of the packages and libraries that we use today, they support getting this key from this endpoint so that you can actually use it without having to know what each of these parts means. But there are two important things that you need to notice here. We know what algorithm usually this key is used for, and we know the key ID, because you can have more than one public key for user depending on how your systems are set up. And let's see some code, right? Because I like to code in Python, don't you? Well, there are a few libraries that you can use to handle JWTs in Python. My favorite one is PyJWT. I'm a little biased, and it does all the cool stuff. So the first thing you want to do is install PyJWT with the cryptography dependency on your Python environment. And then you can just import JWT on your Python console and give it a token, and it's going to do its magic for us. So the first thing I'm going to do is actually import my JWT module. After that, I can copy the token, put it in a variable for me to use as a string, and then the easiest part comes. We call the JWT.decode method, and you pass along the token, the secret, and the algorithms. Now, this assumes that you know the secret and you know the algorithms. Once the decode method does its magic, you are going to be able to retrieve the payload of the token. That means the verification process was well done, was successful. And of course, now I know every little thing that needs to know about this token. I know the secret, I know the algorithms, and once I pass it along to the method, I can see the result in there. And it comes as a dictionary. So you can save that into a variable and use that on your applications whichever way you want. But let's say, for example, that somebody told you the secret, but they forgot to tell which algorithm was used for the token. So that is a way actually you can find that out, and it's using the method getUnverified header. It also gives back a dictionary. So I did the same process. I imported JWT, I put my token in there, and then I use the method getUnverified header, pass along the token. I do a lot of typos when I'm coding. And then I can get the header. After that, I can see the header. It is also a dictionary. So I can put that into a variable so that I can use on my code. So you don't have to actually know beforehand what was the algorithm used. And then I put that header data because, well, what better name? And then I call again JWT.decode, pass along the token, pass along the key. Well, in this case, a secret, because the algorithm is still HS256. And please don't use that secret. It's not the good one. And then pass along the algorithms in the format of accessing the dictionary data. And there you go. After that, we are going to be able to get, once again, my dictionary of the payload. This means that everything was successful on verifying the token. Now, let's say you are not successful. Something goes wrong. What should you do? Well, I have an answer for that. PyJWT actually gives you all the exceptions it raises when something goes wrong. So if, for example, you get an expired signature, it will show you an expired signature. And you, being the good Pythonista that you are, the good developer that you are going to want to try and use that exception to treat it, to maybe log the error. So I did a try except, put my code in, the try, then did I accept. I know this is a possible error. I put the error in there. And then I can use that information to log what went wrong. Because, well, you want to keep track of these things, right? Now, there I'm just printing, so be mindful of that, because it's just an example. But in my systems, I would be logging it out. And then I can use a string that I know, and I can find that information on my logs. And there you go. After I run that, I'm able to see that, well, it didn't blow up in my face anymore. The last part I want to show you in code is there is a possibility that you are not using a symmetrical algorithm, like the examples I just showed you. So you can either request a key, or you can load the key yourself from your machine. In this case, this example token that I have, I created it using an SSH key, so I can load that in using PyJWT. And after I load that in, I can use it with read because I want a string of it. And then I can use the serialization module of PyJWT to load any type of key that you might have. For example, this is a SSH1, but you're going to see that we have other methods in there, like, for example, the PEM type of keys. And I'm going to load my SSH public key because I want to verify the token. I pass it along as a bytes string, so I encode it. And then I can use that back again with my decode method. Now, keep in mind, if you are using a service, as Auth0 as an example, you would have to make a request for the well-known endpoint to get the key, and you need the well-known endpoint and the key ID for that. And there is a way to do that. I linked that information in the description of the slide. This is going to be available to you, so you can check it out. And then again, I put along the algorithm that I'm using. And if everything goes well, you should be able to see the payload data. There you go. Awesome. So now you're wondering, OK, I know everything there is to know about JWTs. I know how they came to life. I know what the payload and the header are. I know that I have a lot of algorithms that I can use, 2 types of them. I know I have claims and so on. But where do I find JWTs in the wild? Where do they live? How do they feed? So the first time I think of JWTs, and the first time that I actually saw one, was actually making requests to protected APIs. So when you are talking about protected APIs, you're going to think about access tokens. So let's say you want to make a request to a protected API. You need an access token to access the protected routes. So the access token is going to have all of the information that you need for dealing with that API. Now, access tokens doesn't necessarily need to be JWTs, but there is a new RFC in the block that came out last year. It was authored by Vittorio Bertocci, Auth0's principal architect, that outlines how a JWT as an access token should behave, what kind of information it needs to have, how the information must be structured, and so on. It's a very interesting read. If you are curious, you should check it out. The other type of JWTs you may find in the wild are the ID tokens. And they are the coolest, at least for me, because they carry information of the user after the user did their login, for example. So that way, your front end doesn't have to make an extra request to get, for example, the user profile. It is going to be able to have that information in there. Also, because we're talking about tokens, you may have heard of refresh tokens. Refresh tokens are not JWTs. That is why I'm not going to be speaking about it, maybe in a new talk. So now that you know how you can use that, JWTs, how they work, how they come to life, how you can structure the information, you may be wondering, well, this seems a little bit dangerous. There's going to be information in there. How do I don't know, be safer with it? Well, I have a few tips for you. So don't store your JWTs in local storage. That's a bad idea, because it opens you up for a type of attack known as XSS attack, and we don't want to do that. Because once JWTs are out there, you cannot call them back. It is a hassle. So don't store that in local storage. If you need to store somewhere for verification process, you may do it in memory. That's the best idea. The other tip is we don't verify JWTs in the front end. Because, well, let's say you have a JWT that was signed using a symmetrical algorithm. You will need to have the key for it for translating the token, for verifying the signature. And we don't want to have that in the front end, because anybody could go inspect elements on your page and get that information, and we don't want to do that. The last one, and I cannot stress this enough, me being an ex-data scientist, well, still a data scientist at heart, don't put sensitive data in the payload of your token. It's a bad idea, because once again, anybody can inspect your web application and get a hold of that token. And then your sensitive data is going to be out there. So it's not a good idea to put that in the token. Finally, I want to give you some tools to help you out, because I know JWTs may be hard. I made this talk thinking of me a few years back that I wanted this content, and I didn't find any. I had to figure it out by myself. So the first one I'm going to tell you is JWT.io. This was made by Auth0. It is going to help you debug your access tokens. And it's going to make your life easier. You can check out right in browser the information of your token. Now, be mindful where you're pasting the token, because if it is a real production token, it's not a good idea. But JWT.io is a safe environment where you can check out your token if you need to. And we don't store the tokens for ourselves, so it's safer. The other one is you may need more information about JWTs because you are very curious about it. So we actually made a handbook with a few examples and use cases of JWTs, and I encourage you to read it. And that was it. I don't know if you have time for more questions, but you may find me again, on most social networks under the handle Temporal, and my slides are on that link, slides.com/jtemporal/PyCon JWT, if you want to check out all the links. That's it.
We don't take a question as part of the presentation, but please come forward and ask Jessica directly if you have any questions, or just swing by the
Auth0 booth. We are on the
today.
line 600. Thank you.
Thank you.
See ya.